Okay, so for this problem, it says a bag contains 4 pieces of papers, each labeled with one of the digits, 1, 2, 3, or 4. So this means like here we have a bag. In the bag we have 1, 2, 3, 4, and then from this bag we just pick 3 of them. Okay, so we could pick this 3, could pick this 3, right? Okay, so the question is, what is the probability that this 3 digits number is a multiple of 3? So if we just pick 1, 2, 3, let's pick this 3, then it's okay, right? So with, let's say, so the 3 digits made of those 3 digits, like 1, 2, 3, we can make 1, 2, 3, or 1, 3, 2, right? We can make 3, 1. We can, how many we can make? We can make 3 factorial, right? We can make 6 6 3 digits numbers. So all those numbers is a multiple of 3. So let's review, like let's recall, if a number, like if 3 digits, let's suppose there's ABC. If this number is a multiple of 3, or 3 is divisible for this number, then what this means? This means a plus b plus c is a multiple of 3, right? We say 3 divisible by the source. Okay, so if we pick 1, 2, 3, okay, yeah. So how about 1, 3, 4? So 1, 2, 3, like 1, 1. If we pick 1, 3, 4, 1, 3, 4, not okay, right? Yeah. So how about if we just pick so totally how many ways? We say from 4 pick 3. Actually we have 4 ways. So we can list all those 4 ways. So we check it out. Let's say so if we pick 1, so 1 could be, and if saying if 1, 2, 3, 1, 2, 4, if we include 1, yeah, we just listed all those 3, all those 4. 1, if we include 1, so 1, 2, 3, 1, 2, 4, 1, 3, 4. If we include 2, so 2, 3, 4. Right? Okay, so we find this one okay, this is not okay. So we just say among the 4 cases we have 2 of them okay, right? So the probability is 2 over 4 or 1 over 2. Okay, just load the spinner PQR and add the result number. What is the probability that the sum is an odd number? So if we have 3 number, if the sum is odd, so should it be like could it be odd plus odd plus odd, right? Or could it be even odd, right? Yeah. Okay. So we have those cases. Or even could it be the first one out? Or could it be like yeah? Or could it be like or So we have only these 4 cases, right? So we just check. Let's say what is the probability for those things. So first one, from here we pick an odd number. Odd numbers are 2 over 3, right? Saying this one odd. Oh no, this is so no, there's a case, yeah. Okay, so this should be even. Okay, and actually no, there's a case. So we have this only there's two cases like O. So first one is even, so even is two, only two, right? So this 1/3. Second one even, always true, always even. Third one is odd. So the one is odd, 1, 3, 5, 7. Oh, all are odd. Okay, so this is 1/3. So plus first one is odd. First one is odd, 2/3. Second one is even, 1. Third one is even or 0. Okay, so only this is a case, right? Only this is a case, yeah. So this problem quite the same, right? As this is talking about the product. So from this spinner, we pick one. From that one, pick a number. Pick a number. Then the product is even. So product is even. Could be even times even. Product is even. Only this way, even times even, yeah. So first one even, second one even, yeah. This problem easy. Okay, so for this one, when a fierce six-sided die is tossed on a tabletop, so die is just like this, is a die, right? A die. Okay, 1, 2, this is die. The bottom face cannot be seen, yeah. So what is the probability that the product of the numbers on the 5 faces that can be seen is divisible by 6? Okay, so all the numbers are just so. So the problem, all the numbers is 1. So product for those numbers is 1 times 2 times 3 times 4 times 5 times 6. Right? So sometimes if the bottom one is 6, then product becomes this. If bottom one is this one is 2, then this product is this. So this means like we have these 6 numbers. We just remove 1, then just consider the product of remaining 5s. So this remaining 5 is divisible by 6. So what is the condition for this? Divisible by 6. So we say 6 is 2 times 3. So this means, okay. So we say like okay. So when this numbers is not divisible by 6. So we found if we remove this, we still can, this number can be divisible by 6. We have 2, 3 here. If we remove 3, we have 2, 3 here. So if we remove 4, we still have 2, 3 here. So this means this number always is divisible by 6. Okay? Okay, so here toss the coin to the nickel 4 times. Okay, so like toss the coin many times, So here toss a coin, let's say. So what is the probability toss a coin 4 times? So he gets at least as many heads as tails. So we can say like let's say head, tail. So we just listed all cases. At least he gets at least as many heads as tails. So this means heads should be larger than t, right? Okay, so we can list all cases. We have 16 cases. So we just count how many satisfy this requirement. So this is we can use this way, but the other ways we check. We need so 16 also too many cases, right? Even though we can list them, list all of them, but it take some time. So let's consider other way. So we say we're talking about this. So for we just split this into 3 cases. Like h is larger than t, or number of head is larger than t. Then h less than t, or h equal t. Right? We have there's 3 cases. But for this case, this one, this one, by symmetric, they're the same. Okay, so we can regard this probability, the probability for head is larger than t, larger than tail is p. Then this is also p, right? So there's a probability head less than t is also p. So plus this. So what is this probability? So head equal t. So should it be head only like a two head to t, right? So this probability. So we have like 2 head to t. So how many is those probability? So 2 head could be this 2 head to t, right? So for each one is just the half. So head is half, t is half, tail. So 4. Then how many ways? So this we just we from 4 positions, just from 4 choose 2 positions. So put there's 2 as h, right? Then other 2 as t. So this equal 1. So we can find p, right? We can find p, and the answer is p plus this number. Yeah, p plus. So for this, what is this number? This number 6 times 16, right? Or we just say 6 over 16. So p should equal so 16. So p should be 16. 5 over 16, right? For other one is 10, right? 10 over 16, so the total is 16 over 16. Okay, so answer is equal. This case 6 over 16 is equal. Then large 5 over 16, so this equal 11 over 16. this problem is easier. So what is the product of the two number is 5. The product of the two number is multiple 5. So the product multiple 5. So should it be 5 times of, should at least have this 1 5, right? So 1 5 or 2 5, or could it be 5 or 5, or could it be 5 multiple others? Or we just say simply, we just at least have a 1 5. This one we don't care. Okay. So there's a problem. 2 dice are drawn. What is the product? So first one, second one. So we just need to have 1 5. So there's could be first one 5. So second one doesn't matter. So what is the probability? There's a probability is first one is 5, 1 over 6, right? So second one doesn't matter, anyone. Then plus, so could it be like first one, or could it be the second one is 5? Okay, second one is 5. So second one is 5. First one doesn't matter. So it seems answer is 1 over 3, right? But here a trick is first one, second one we don't care. Second one can be like 1, 2, 3, 4, 5. So this one, second one's 5. First one doesn't matter. 1, 2, 3, 4, 5, or 6. But we find like 5, 5. The first one 5, second 5. First one 5, second one 5. We count this twice, right? So we need manage this case. Okay. So other way is, okay, so this should be actually correct answer should be 12 or 11, right? Or we just list all the cases, like let's say 1, 2, 3, 4, 5, 6, 1, okay, then 2, like 1, 2. Okay, so there's a total 36 cases. So then 5, yeah, 5. So 1, 2, 3, 4, 5, like that. So let's say, so here how many cases? If the first one, second is 5, 1. And here how many cases? 1, right? 1, 1. And 3, 1, 4, 1, right? So how about 5? So 5 we have 6, right? 5 each way is okay. So how about 6? First one 6, then here only one case, 1, right? Only here 5. So totally is 11, right? Okay. So a point is chosen at landing from within a circular region. So here we have a circle. So from the circle, pick a point here, pick a point here, like that. So what is the probability that the point is closer to the center? So center is here, closer to the center, then it is to the boundary. So we just check where the equal. let's say, okay, so let's suppose this is 1. So this is a point, half, right? Okay, so this point, this thing to the center and this thing to the boundary same. Okay, so those points, okay, right? So we say, so here we say, so if we pick a point in within this part, saying that these things, this point is closer to the center than to the boundary, right? Okay, so the probability is we pick a point from this circle. So what is the probability? We just pick it inside. We just pick it from this inside. So this probability is just the so we just check the area. So here, suppose the radius is 1, so total area is pi. So we can, from this, like this range, we can pick any point. Then the requirement should be this circle. So here pi, so r is 1/2 pi r square. So this should be 1/2 square. Let's say, there's a problem. Okay, let's consider the problem. If 2 dice are tossed, the probability that the product of the number showing on the top of is greater than 10. So the number, so here could be the first one, could be 1, 2, 3, 4, 5, 6. Second one could be 1, 2, 3, 4, 5, 6, right? So product could be also product. So product is larger than 10. So we just check this. At first we say totally, first one, second one multiplied together. So totally we have 36 cases, right? 6 times 6. So if first one is 1, then the product cannot be larger than 10. 2, can, if we pick a 2, so we just check how many cases. If the first one is 2, then second one is 6, so we have one way, right? If first one 3, then could it be 4, 5, 6, right? So 3 ways. Yeah. Like first one is 3. First one 3, then could it be 4, 5, 6, 3 ways. So first one is 4, could it be 4 ways, right? 3, 4, 5, 6. Yeah. And 5, 5 also could be 4 ways. So 2, 3, 4, 5, 6, but cannot include 2. So here's a great thing. If first one is 6, then could it be 5? Like could it be, if there's 6, so could it be 2, 3, 4, 5, 6, 5 way. So the answer should be like this. So total is 36. So here, what is this? 10, 17? Yeah, 17. Okay, so we leave that as a problem. That's easy. So, okay. For this problem, it says a bag contains only blue ball and green ball, but we don't know how many, right? So there are 6 blue balls. Oh, we don't know green ones. So let's say we have 6 blue ones, but for green ones, we don't know. Suppose we put X, we don't know X, green one. If the probability of draw a blue ball at landing from this bag is 1/4. So let's say what is the probability? So we know the probability is 1/4. So this probability is from 1. We just pick 1. We get this is blue one. Such a probability is 1/4. So how can find this 1/4? So we just say, so 1/4 is calculated this way, right? Totally blue one we have 6, and totally how many in all? We have 6 plus X, right? So this equal 1/4. So we can find X. We can find X easily, right? Okay. The problem says we have 10 balls numbered 1 to 10 in a jar. So we just randomly remove one of 1. So here we have like this 1, 2, 3, 4. So we have 10 balls. So just remove 1. Okay. Just remove 1, then gel reached into the ball and landing but remove a different one. Remove 1, then remove another one. Yeah. Basically, first guy remove 1, second guy remove 1. So the probability is the question. The probability is that the sum of the two numbers on the ball removed is even. Is what? Okay. So there's a problem. Just from the 10 numbers, pick 1, then pick 1, then add them up. We find this even. Okay. So this even. So that means the first one is could be even. The first one odd, then second one odd, then we get the even. First one even, second one is also even, so we get even, right? So we have these 2 cases. So let's check this probability. Okay. So for this one means first one remove 1, or you take 1 or get 1, you get this is odd number. So from 1 to 10 odd number, we have 5 or 10, right? Then second one is so by now we have remaining, we have 9 of them. So you also just take an odd number. So here we have 4 odd number, right? 1, 2, yeah. So 1 odd number, 1, 3, 5, 7, 9, yeah. So if we only pick 1, so we have 4. Then for this E plus B, first number is even. First number is even 5. 2, 4, 6, 8, 10. Yeah. Then second one is another even 4. Okay. So the answer is this plus this. So we find this 2 the same. So this is just equal 10, 5, 9, 4, 9. So multiply 2, right? Multiply 2. Also, this cancel. So that's equal 4 over 9. Okay, so we can stop here.